Hello everybody listening to the new episode of the Eltex Electrostatic Snacks. Today we have something about charging, electrostatic charging of non-woven filter material. Take a look at the material properties. Depending on the intended purpose, filter material for masks has to fulfill several conditions. We need a good absorption of particles, which needs a small pore size, results from tight woven or thick fluffy material. We need a good airflow rate, which needs a big pore size, results from high porosity. And we need a good filtration stability for a long time, results from no particle is stuck to the filter, we have no drop of airflow. The first two conditions are a matter of machine equipment or adjustment. The filtration stability is a matter of material and especially treatment of the material. And by the treatment, we can do something with Eltex charging. The production: a melt PP polypropylene resin is blown to small fibers with hot air in a special die and collected on a belt in a certain distance to the die. A special additive for charging later is needed in the resin. Very interesting here is the DCD, the die to collector distance. We have some diagrams here for it. The average diameter size of the fibers is almost about 2 micrometer, which is with the die to collector distance from 10 to 35 centimeter almost the same. The average pore size remains also the same, and the porosity is getting higher with a higher die to collector distance. The pore distribution, the pore size, the average pore size of 50 micrometer stays the same over the whole die to collector distances from 10 to 35 centimeters. If we have a higher DCD, the pore size and fiber thickness remains the same. The porosity gets better, the melt-blown filter material gets more fluffy. A special look at the pore size. We have here a picture, a microscopic picture of a typical melt-blown PP filter material. The pore size is up to 50 micrometer. Here you see something with some dusts, pollen, hair, fog, cement dust, tobacco smoke or something else. And you see here with a pore size with 50 micrometer, we do not get really out all of them. Very actual topic is to get out aerosols and viruses with about 0.01 to 0.1 diameter. And this only can be done with a treated material which has a very good absorption for these particles. How can we do the charging? You see here the filtration efficiency. The efficiency before charging, the blue line, with the DCD from 10 to 35 is getting smaller, less. It's decreasing a little bit. But after charging, you have here a very high efficiency of the filter. And the pressure drop is almost always the same, is getting a little bit better with a higher DCD. So a good material at a DCD of 30 centimeter has after charging an increased efficiency of the filter from 50% up to 92%. and the pressure drop almost remains the same. We have two charging methods. First, the charging method 1. We have here our producing of the non-woven material with collecting on a belt. We place the power charger and a charging electrode R130 over the fiber material, and under the fiber material we have a grounded counter electrode. The distance between the R130 and the counter electrode is 30 to 50 millimeter. To get the high charge, we need a charging time up to 30 seconds. So maybe R130 in serial are needed. Here we have 3 in serial. The warm material can influence the charging to the better. Now the charging method 2, which can be also done with a cold material, long after production. This charging of non-woven material is regarding to a US patent of Professor Peter Tsai. We have here some grounded rollers. The material is getting around the rollers, and on each roller we have the charging. We charge against blank grounded roller. The more looping we have, the better the charge is. We use 2 polarity, negative and positive, and a special additive for the resin is needed to get the charge to stay on the material. The improvements we have done, we need 2 electrodes for each polarity, negative and positive, and we need a milliampere per meter of electrode of about 3 to 7. Let's talk about the safety. Be careful when charging. In case the charging equipment, make a protective shutdown of the generators when opening the housing of the electrodes. Charging produces ozone, maybe a suction is needed. A high wear, especially of the positive electrode, can happen. Also a deposit or a blooming on the grounded roller is possible. So now the summary. Charged non-woven material has higher efficiency for filtering particles. The charge stays on the non-woven also after washing or cleaning with vapor. A current of 3 to 7 milliampere per meter electrode is needed, depending on customer conditions. The power charger can deliver up to 7.5 milliampere. If the electrode has to be longer, take 2 for the web width and 2 generators. The warm material can increase the chargeability of the material. 2 methods of charging non-woven are well known, with rollers or on a belt. To charge the material, special additives are needed in the material. Take care of the safety when charging. Hope you enjoyed our short excursion to charging filter materials. Don't forget, we are the experts. And if you have further questions, don't hesitate to contact us.